Hey guys, welcome back to the next video. In this video, we are going to understand about the namespace and C grouping. Now, in terms of the architecture, I have the architecture over here, which talks about what internal functions are going to be done by namespace and C grouping. Now, if you're not sure about this, we have discussed about namespace and C grouping on our previous architecture, wherein which I've told you the run C manipulates your container using namespace and C groups. So I'm just going to understand what it is. Now you might see the word change from control group to C group, but it's called control group, but you can shortly call it as C group. Okay, so that's why there is a name change here, but I prefer calling it C groups. Much easier and faster. What does each of this well, in terms of namespace, right? So namespace, the first one which you're going to talk about, PID namespace, which is process ID namespace. So what it controls is that every time you create a container, the process ID namespace isolates the process such as namespace, which has its own process hierarchy. All right. This allows process inside a namespace to have a unique set of process ID, which is PID, making them unaware of the process outside the namespace. So PID namespace are basics of process isolation in terms of container. So that kind of a process isolation is being provided by your kernel feature called namespace. I'm sorry, I just accidentally scrolled. In terms of the next one, which is mount namespace is going to isolate the file system mount point, creating a separate mount tree for each namespaces which you're creating. So when a process within a mount namespace can mount and unmount file system without affecting the global file system namespace. Mount namespace enables the creation of container file system within their root file system, isolating the host from the containers file system. So when you go inside a file container, when you have the option of, I will tell you how to log in into your container. When you do so, you will see a completely different root file system from /. Okay, now that is only possible because of mount a namespace. Now the next one we are going to talk about is a network namespace. Now how important is the network namespace is, the network namespace provides network isolation by creating separate network stack for each namespace. Each network namespace has its own network interface, IP address, routing table, and firewall rules. Network namespace allows container to have an isolated network configuration and communication. As when I say isolate, it means it's going to isolate from host. It's going to isolate from the other containers. In terms of IPC namespace, the IPC namespace is isolate the inter-process communication. So what this means is that there are this message queues, semaphores, which actually communicates with, which is used for communication, right? So this IPC, inter-process communication, will be isolated using the IPC namespace. So I can control how and where the communication needs to happen from my container to what, or from outside to my container, how the communication is going to happen. In terms of UTS namespace, the UTS namespace isolates the system identification and the host names. The processes in the different UTS namespace can have distinct host names, preventing conflict and providing a unique system identification within a namespace. The next one is the user namespace. This enables us to allow mapping of users and group ID from the namespace of the host group IDs and usernames. Now, host server will not have any affiliation with the containers, and each containers will not have any affiliations towards the usernames and group names, because everyone is going to have individual username and group names. thanks to the feature here, which is called user namespace. In terms of control groups, let's just go over here. So the first major item over here for control group is resource allocation. It is to understand the resource the system has, the hardware has, and then align those requests accordingly is what is resource allocation is all about. That's what control group controls. Now, the word control, you can understand where it came from, right? It basically controls the flow, and it also does the enforcement of resourcing. Okay, so we'll discuss about it. In terms of CPU, CGroups allows you to allocate and control the CPU resources for a group of processes. It provides features like CPU quote, limit, real-time scheduling for process groups. In terms of memory, CGroups manages the memory utilization of processes in a group. It allows to set a memory limit, which makes sure that it controls the memory utilization and handles the out-of-memory condition within the CGroup. And in terms of resource allocation, we have to talk about this I/O as well, block I/O. So which is basically the block device I/O operation, input-output operation for process in the CGroup. So this basically controls that. It limits the priority disk I/O for the group of processes. So it controls that, and it also limits that. In terms of network CGroups, it includes a network CLS and network priority, enabling the control of network packet classification and prioritization. So this is as part of the network in terms of resource controlling. So likewise, it actually acts as an isolation for resourcing, as in like the CPU, memory, and the disk, including network. It will be isolating from each and every containers. It will make sure that the container doesn't breach that, whatever the threshold it has set as part of setting up that particular container. It also does monitoring of your container. Sorry about that. I have a bad handwriting, I would say. And then it does the resource enforcement. So enforcing the resources, making sure that it doesn't breach any of those within the limit. So it's going to do that as well as part of control groups. If you have any questions about this, do leave me a question on the question section. I'll be able to answer it to you whenever I get some time. Thanks again for watching this video. I'll see you on the next one.